Okay, my name's Andrew. I work at Intel. Probably through this talk, you might guess that I work on a very large and somewhat old code base, but the title of my talk is Don't Fear Custom Clang Tools. Okay, so I'm going to talk briefly about what Clang tooling is, and then two applications, large-scale refactoring and dead code elimination. I'm just going to make sure. All right. Basically, Clang tooling is a set of standalone tools for C++ developers. The three kind of applications I see used are automatic formatting, refactoring, and code checking. A requirement is that your code has to compile in Clang, but every time I've tried to get something to compile in Clang, I found bugs, so it's been a positive experience in my code at least. Immediately when you get it to Clang, you win Clang Tidy, which is an excellent C++ linter. The classic example of something you can do with Clang Tidy, and they have an awful lot of rules, but you can go and you can check your code base to see if you've used override properly. So in this case, you have a base class, a derived class. I'm looking to see if there's an override here, and when I run the check, it will warn me that no, it wasn't there. But as a bonus, at least with this rule, it's got a fix option, and the fix option will insert the override back into your code. And it's partially doing this because the reason you had to get this all to compile is it's going and it's constructing an abstract syntax tree of your program, so it basically has access to the details of whatever you fed into it. So you may go and you may try this out. It might be awesome. Everything works. You may go and try it out, and you might find out that the real world is messy. And you may be looking and saying, I don't even care about overrides. This is not interesting to me. But the first app that I really was interested in this for was large-scale refactoring. So in this example, I've got a piece of code. I've got a car. I'm going to add people into my car. The class assumes ownership of the people, and there's an order to it. And I've got a bit of code that uses it where I'm adding a driver, I'm adding a kid, I'm adding a dog. The dog is not a person. And I'm adding grandma to the trailer. The trailer is not a car, but grandma is a person. So I want to refactor this code to look like this. I want to say pushback because I'm adding to the end, and I think that will help people understand it. And I want to use unique pointers because it's 2019. So I have to fix all of my call sites. Because I go and I have the information about the types, I can go and I can say, I'm going to match for car, I'm going to match for add, and I'm going to match for a pointer to a person. I can do basically a text substitution where I get rid of the add and I say pushback. I can extract out the driver here, or whatever you use to get that driver pointer, and I can wrap it in my unique pointer, and I can say, well, there, my refactoring is done. I skip the dog is not a person, and I skip grandma because the trailer is not a car. The second app we have is dead code elimination. So we'll have code that looks like that. We'll have the add. We'll get the type of the car. The car will be a Renault, and we'll say, well, if the car is a Renault and the color is black, we want to do a case. Otherwise, we have a second case we're going to do, and we'll have some intern look at this. They'll go look at case number 1, try to understand it, and that's when a senior developer will say, we have not supported Renaults in forever. Like, that was so 10 years ago. We never have to worry about that. That's dead code. So we can write a Clang rule that goes and checks and sees if I'm comparing a car type to Renault, that is really false. I can substitute the false in there. I can do a second pass where I say false and any expression is also false, and I can then substitute that in. And already I am improving the readability for the intern, because at least now the intern can go and look and say, that is dead code. That is very clearly dead code. I don't have to have any special knowledge. But I can do a little bit better than that. I can get rid of the whole if branch. And now I've gone and I've potentially taken do case 1, and I've made it so that nobody's calling it. And then it becomes very clear it's dead code, and we can have somebody go in and just remove it. Last thing, the first time I wrote a Clang tool, it was 4 days of dev time, meaning I had to sit there, I had to go through a whole bunch of abstract syntax tree documentation. I had to look at people's examples, try to puzzle it out. I had to get CMake to work. Second one, because I had a starting point, was 4 hours. Third one, 2 hours. I'd like to say it keeps on geometrically decreasing, but that's not the case because eventually you get more ambitious with your tools. So thank you.